You know, from the smart speaker that plays your music to the thermostat that keeps you warm, our homes are just packed with these connected devices. They make life so much easier. But here's the catch. Every single one of those devices is a potential doorway for an attacker. So today, we're going to dig into some really cool research that's building a new kind of AI security guard, one that protects our smart lives from the inside out.
All right, let's just jump right in with a number that is, frankly, pretty staggering. Malware attacks that specifically target our Internet of Things devices, all our smart home gadgets, they've shot up by 400%. And that's just in the last 4 years. We're not talking about a small leak here. This is a full-on flood.
So you got to ask, right? Why? How can these devices that are designed to be so clever, so smart, also be so ridiculously easy to break into? Well, the answer to that is the puzzle we're going to solve today, and it's got some really fascinating clues.
And this gets us to our first section, the smart device dilemma. See, on one hand, we've got this amazing explosion of super helpful IoT devices. But on the other, the security methods we've been using for decades, they are just completely failing to keep up. Think about the antivirus software on your laptop, right? It basically works by recognizing the fingerprints of known bad guys. But that whole approach is way too slow for the world of malware, which changes every single day. And, more importantly, those programs are huge and power-hungry. They're just too big to run on the tiny little microchips inside your smart light bulb or your coffee maker. They can't even fit on the very hardware they're supposed to be protecting.
So, to build a better security guard, you first need a totally new way to see the threat. And this is where AI comes in. But of course, that brings up a whole new question. What's the best way for an AI to actually look at a computer virus? And that's where we find the first big breakthrough.
I mean, it's a fascinating question, isn't it? If you're an AI, how do you even approach this? Do you read the malicious code line by line like it's a book? Or do you look at the whole thing at once like it's a picture and search for weird patterns? It turns out the answer makes a huge difference. So let's break that down. The first way is what's called a 1D, or one-dimensional, representation. Here, the AI just reads the raw code as one long sequence, like a story, from page 1 to the end. The other way is a 2D representation. You take that same code, turn it into a grayscale image, and the AI looks at it like a photograph, trying to spot suspicious textures and shapes. And this is where it gets really cool. When the researchers tested both, the 1D models, the ones reading the story, they got the exact same high level of accuracy as the 2D models. But, and this is the kicker, they did it while being 22 to 37% smaller and way more efficient. For a tiny chip in an IoT device, that difference isn't just nice, it's everything.
So the first big clue we've uncovered is this. When it comes to malware, it's actually much better for an AI to read the story than to just look at the picture. All the important stuff is in the sequence, the flow of the code, and the 1D approach gets right to the heart of it without all the extra baggage.
Okay, so we've got our first clue. But any good detective knows one clue is never enough to solve the case. So let's move on to the next part of the investigation. Because it turns out, malware doesn't just have one story. You can actually read it in 2 different languages, and you really need to understand both. So what are these 2 languages? Well, the first is that byte-level code we were just talking about. Think of this as the raw ingredients of the malware. The second is assembly-level code. That's what you get when you disassemble the bytecode. This is more like the step-by-step recipe that explains what the malware actually does. Most security systems out there only look at one or the other.
And here comes the big aha moment. The researchers trained an AI to be an expert in just one language. Let's say the ingredients. Then they asked it to try and understand the other language, the recipe. The result? A reconstruction error of over 200%. That proves these 2 languages aren't just saying the same thing in different ways. They hold fundamentally different, complementary pieces of information.
And boom, there it is, clue number 2. To really see the whole threat, you can't just look at the ingredients, and you can't just look at the recipe. You absolutely need both. This idea really flips the script on how malware detection is usually done, and sets the stage for a much smarter approach.
So, now we've got 2 huge clues. We know that reading the 1D story is better, and we know we need to read that story in 2 different languages. Armed with that knowledge, the researchers built a totally new kind of AI. Let's call it the hybrid detective.
And here's a look at how this thing actually works. It's called the HCL-Classifier, and it has these 2 parallel paths. The first path is an expert at analyzing the raw ingredients, that byte-level code.
The second path is a specialist in understanding sequences, perfect for following the recipe in the assembly code. Then, at the end, they bring their findings together to make one final, super-informed decision.
So, does it work? Oh yeah, it works. On a huge Microsoft malware dataset, this hybrid approach nailed it with an incredible 99.91% accuracy. It's definitive proof that by combining these two different views, the AI gets a level of understanding that's just way more powerful than either one alone.
Okay, so we've built this genius AI detective. It's incredibly smart, unbelievably accurate, but there's one last huge problem we have to solve: making it small enough to actually fit onto our tiny smart devices. This is the deployment challenge.
And this really is the ultimate question, isn't it? The hybrid model is powerful, for sure, but it's still way too big and complex for a device with barely any memory or processing power. So how in the world do you shrink it down without making it dumber?
The solution is this brilliant process called knowledge distillation. The best way to think about it is like a grandmaster AI teacher and a student. The huge, complex hybrid model, that's our teacher. But it doesn't just give the smaller student model the answers. It actually teaches the student its intuition, all the patterns and gut feelings it has learned. This lets the student become incredibly smart without needing the teacher's massive brain.
So you've got this contrast. On one side, there's the big, powerful teacher model. It's super accurate, but it's just too chunky for the real world. And on the other side, you have the student model, a lightweight, streamlined AI that's built from the ground up to be lean and fast enough to run on pretty much any little IoT device.
And the results are just fantastic. Through this process, the student model ends up being around 60% smaller than its teacher. But here's the amazing part. It still holds on to 98% of the teacher's incredible accuracy. We literally get the best of both worlds, a security guard that's both a genius and small enough to fit anywhere.
All right, let's bring this all home. This whole journey has taken us from figuring out the core weakness of IoT security all the way to building a real, practical, and powerful solution. It's all about being smarter with our defenses, not just bigger. So it all boils down to three huge breakthroughs. First, how you look at the problem matters. Treating malware like a 1D story is way more efficient. Second, hybrid is better. Analyzing both the ingredients and the recipe gives you the full picture. And third, knowledge distillation makes it all possible, letting us put this powerful AI on the tiny devices that need protection the most. So what's the big takeaway here? Well, we finally have a real workable blueprint for securing the billions of smart devices that are all around us. This research gives us a powerful new guard for today's threats. But it also leaves us with a really important question to think about. As attackers get smarter and start using their own AI, how are we going to keep adapting and building the security guards of tomorrow?